Maybe let's start with some of the things that you edited from your books, 97 Things Every Programmer Should Know. Maybe if you can distill 3 to 5 key lessons, because we won't be able to cover 97 things for sure. What would be some of your advice for developers here? What things they should know, what gotcha they should avoid, or maybe just some things that you think they should, dive deeper.
Yeah, I think that's an interesting one because obviously there are 97 things in each of the every programmer should know and every Java programmer should know. So therefore, what are 3 or 5 that I would choose? It's difficult to pick favorites, but actually what I might do, the easiest way for me to kind of pick a few is just to think of the ones that I've used in the last week or directed people towards in the last week. Here we are in 2022. The 97 Things Every Programmer Should Know, that book was published in 2010, and 97 Things Every Java Programmer Should Know was published in 2020. But the funny thing is the first book's 12 years old now, and 12 years is a long time in software development. And yet I keep going back to the pieces of advice in that book because they are relatively timeless. You won't find mention of microservices, but you will find mention of functional programming. You will find mention of caring about your dependencies and your structures and all the rest of it. The names that we use for various things have shifted, but actually a lot of the interests and good ideas are surprisingly stable and timeless. So I often use these in my talks because I think it's also good to point out whenever I'm talking, I tend to regard what I'm doing as I'm a clearinghouse. Everything I teach or communicate typically came from somebody else, and it's synthesizing these and put together. So I think it's always really kind of important to highlight that. In the last week, one of the ones that I've certainly referred to is Burke Hufnagel's piece in 97 Things Every Programmer Should Know. He also contributed to Every Java Programmer Should Know. But the one that I always come back to in 97 Things Every Programmer Should Know is the piece entitled, Put Down Your Mouse, Step Away from the Keyboard. I like this because it works on 2 levels. First of all, there is the general advice of the piece, which is exactly captured in its title. The idea is that sometimes when you've been beating your head against a problem too closely, you've exhausted everything that you can do at that level, that detailed level where you are concentrating intensely, looking at the screen. That line of opportunities run dry, otherwise you'd have solved it. You've done everything you can at this level, and doing more of it is not going to help. So therefore, at this point, the thing you have to do is disconnect, disengage, go do something else. And I think that the lesson of this is psychological in the sense that this tells us a little bit about how the brain works, that you are very much in this kind of focused style of thinking, which is not necessarily creative. You may be focused on detail. You're trying to understand how things fit together, very detail-oriented, very procedural, and that flushes out a certain class of problems and issues. But the associative, connection-oriented style of thinking, the more lateral thinking, that doesn't normally happen at the same time, or you can't force it to happen. And that, I think, is also a huge reminder to us, because I think many people work in environments where the most common thing I get asked, what if we don't have time? We don't have time for this. And it's just like, you know what? You do have time. It's just that the thing you're not good at, and I don't mean you as picking somebody else, I mean you as a human being are not necessarily good at, is knowing how to use your time. This is not a strength that we have. We're very poor at this. And actually, if you want to save time, then stop working. This is counterintuitive for some people. It's like, no, I need to put in more hours. I need to put in 2 more hours on this problem. It's like, actually, you're probably going to solve that problem by not working on it. Go and do something else. The solution will come to you, 5 minutes, you'll have solved it. You can't tell when that 5 minutes is going to be. Maybe it's while you're having breakfast. Maybe it's while you're showering. Maybe it's while you're on the subway on the way home. The point there is that once you've let go, your brain is just no longer concentrating on that, and the ideas will connect. You've got to kind of trust the fact that you're not trying to control the process, that it'll happen. So that's the kind of the broad message of his piece. But I also like his piece because he shows a concrete example where he experienced this. It's a piece of code, and he shows us the tidied up version. He shows us the piece of code after it's been refactored, and it's really messy. It's complicated and procedural. It does the right thing. But then he steps away and realizes, you know what? This is just a pattern matching problem. I'm trying to approach it with kind of ifs. That's what I tend to see in a lot of code. Oh yeah, you're trying to solve the problem by using a lot of ifs. If this, otherwise, it's just like there's something simpler waiting to happen, and you just don't know what it is. He reveals that. It's one of those things of like, take the foot off the pedal, and a lot of things get solved. So thinking is important in software development. Therefore, you've got to learn there are different ways of thinking, and some of those are not about pushing yourself. They're exactly about pulling yourself away, the exact opposite. So I really like that piece because it has a detailed technical message showing us perhaps where unmanaged technical debt comes from and how code can become complex through no fault of our own. but it also shows us the relationship that we have with time and our attention and code. So that one, I think for me, always sticks out as quite a big one. Another one I'm going to pick on, although this is a little bit self-serving because I wrote it, but it seems to have come up a lot in the last couple of weeks. The title tells you everything. It is a piece on comments. Comment only what the code cannot say. The whole question of comments is an interesting one in software because comments are code that is not code. In other words, they don't have a formal syntax. They are code that is not code, which means that they don't get checked for correctness. Most comments are wrong, and if they don't start out that way, they become that way. But because they don't trigger a compiler error, and they don't fail a test, and they don't cause a bug, our attention is not drawn to them. So they don't have a process that causes us to correct. If you broke the build, you're going to go and fix something, okay? That's the thing. But if your punctuation is a bit messy in your comments, that's not going to cause anything. If you're stating things that are factually incorrect, that's not going to cause anything. And so people have these various different philosophies of comments. And it's an interesting one because it's a kind of like we have this absolute freedom. Absolute freedom is quite a frightening thing. People don't know what to do with it. And so we have these observations about, okay, yeah, comments become out of date and all the rest of it. But we also have this desire to be helpful. We want to help people. There are two extreme schools in this. One school of people is like, don't comment your code. All comments are bad, all this kind of stuff. Your code should be self-documenting. From one perspective, I look like I lean a little bit more towards that camp. But my system of belief on this one is slightly different to the way that these are articulated. The idea is I don't think that all comments are necessarily bad. That's not the useful position. I also don't think that saying that you shouldn't have comments automatically improves your code. Although I've seen code which would be improved by deleting the comments, I don't think it's an automatic consequence. So there's a lack of nuance. I find most of the advice saying don't comment, your code lacks intelligence and nuance. You want to understand why. But at the other end, the comment everything crowd is just like, it's just noise. And I've seen far too many examples of that fail. So the way to understand this is don't comment what the code already says. That's a fairly standard piece of advice. So that tells us some of the things we don't want to do. But there's a really interesting connection here between understanding what it is that you're trying to communicate. So for me, there's a deep message here. What am I trying to say? How am I communicating? And what is then said in your code? And for me, that's the driver. It's like, what can I say? Why would I want to put a comment here? I would want to put a comment here because the code is not obvious. It doesn't say it's not obvious what I'm saying here. Okay, so recognize that as a need. That doesn't mean you need a comment, yeah? It just means, there's a communication shortfall between what I'm looking at on the screen, what I've just created perhaps, or what somebody else has created. There's a communication gap between that and the thoughts in my head, what I feel I want to communicate. We're not saying everything that we want to. So that's a good first candidate for maybe why we want to comment. But don't do it just yet. What is it that you would want to say? And then suddenly say, hang on, could I say that in the code? Could I say that in the thing that is going to get checked? Or am I just apologizing for the code? In other words, if I've got a variable, A, and I put a comment, A is for altitude, then I'm apologizing for the code. Why don't I call it altitude? There you go. I've got a better name for it. In other words, I can say it in the code. If I've got a big block of code and I've got a big banner up at the front, then it's kind of like, well, why is this not a method? Because that's what a method is. It's a named block of code. You know, when we see large methods that are hundreds, if not thousands of lines long, there are two thoughts here. It's just like, why are we not factoring this out into methods? That's what they're for. They are blocks. That is what a method is. Fundamentally, it is a captured block with a name and a clear set of parameters. And if that deserves an appropriate Java doc style comment, then that's fine, because that comment is for external documentation. It's not for the reader of the code. It's for the user. That belongs to a documentation set as opposed to being something that is in line with it. So that leads to the advice. Comment only what the code cannot say. Not what the code does not say, but what can't it say? In other words, what can I do to get to the point? And the way I often motivate people, imagine you didn't have comments in your language. Now write the code. Write the code if you didn't have comments. Right, now you've done that. Is there anything else you'd like to say to the reader? You've said everything you possibly could. Whatever is left is the thing that cannot be easily communicated, that you couldn't say in the language. Now you have your comments back again. And at that point, your comments increase in value. That's the key. To have things that are of value, one of the ways we drive value is scarcity. A kilogram of iron is worth significantly less than a kilogram of gold. Although iron is technically more useful as a material, the higher value of gold is defined by its scarcity. If you had as much gold in the world as there is iron, a kilo of gold would be worth a lot less than a kilo of iron. Not a very useful substance in that quantity. So the idea there is scarcity helps define the value. If you put comments everywhere, they're worth nothing. So for me, that's something I find on communication to people. It's much more balanced way of thinking. And it caused me to think about, how do I value these? What do I think is a useful way of thinking about this? Probably a third piece. I don't think there's a specific third piece, except that I would say what's interesting in both of the books, the 97 Things Every Programmer Should Know book and the 97 Things Every Java Programmer Should Know book, is there is a really strong emphasis. People are really consistent on testing. I get a lot of pieces and very well written pieces on testing. This idea that is part of the coding cycle, that is part of the fabric of software development. It's not something else. It's not there is software development and there is testing. Testing is a part of software development. That is a consistent view that has been with us for a while, but perhaps I think there is continued scope for improvement on that. I think we can always do that. We can always do that better. And in fact, there's a really nice piece in 97 Things Every Java Programmer Should Know from Maurice van Dijk on this, where she really breaks down the value of communication in testing. So you can actually find all the book items online. Somebody moved it into GitBooks. I intentionally created the book with a Creative Commons license so that people could do that. So there's a GitBooks version of it. For 97 Things Every Java Programmer Should Know, we took submissions through Medium as well as through a kind of Google Form style thing. But all the Medium stuff is still online, including Use Testing to Develop Better Software Faster by Maurice van Dijk. Marie breaks down really the intention about what makes a good test. That's the other thing that I think is really important, is the idea, again, think of your tests as communication. Tests are not merely checking. Anybody who's kind of communicating, oh yeah, tests are just checks. You have totally missed how to do testing in software. But sure, they have value as checks, but that's not the full story. That's kind of the sound of one hand clapping. It's like it's part of the story, but you've really got to understand it's an act of communication. That makes the story much, much bigger. It reframes the way you think about tests. Tests are not merely checks. They are an expression of intention. They're a form of communication. They're kind of an opportunity, not only for somebody else to understand what's going on, but they're also an opportunity for whoever's writing the test, whether you're doing that on your own, as a pair, part of a mob, of trying to say, well, what are we trying to say here? And that's actually the hardest thing. The mechanics of the test are something I think we get drawn into a lot, but actually that's not the hard part. The hard part is, what are we actually trying to say here? That is the challenge. So that, for me, is the most important thing about testing. Tests are not second-class citizens. They are an opportunity to express something that perhaps, again, you could not say in the code. So this connects with what I just said about comments, is we have all these other means of communicating our intention. And again, sometimes I might be writing a piece of code and I say, okay, here's a thing I couldn't say or is not easily said in the code. And I might start writing a comment and I say, well, maybe if I showed you an example of interaction, what a great idea. An example of interaction. Here's a piece of example code. It shows the interaction that's of interest. And just to make sure that we're all good, I'll put a bunch of assertions at the end. Bingo, you've got a test. You've communicated intention. You've created the test from understanding that you were trying to say something that was not otherwise easily said. So for me, these form part of a thinking system. Sets.
I know it's very hard to pick favorites from the 97 times 2. I don't know whether there are any overlaps from the two books. Just to summarize, the first thing is about being detached from working in tents for a long time, right? So sometimes we as developers, we crank the code, we just rush and we just deliver features over features. Sometimes when you are in this kind of coding mechanics, we tend to probably don't see a pattern that we can improve in terms of maybe problem solving,
exactly,
looking at the code and things like that, or even ideas how we can do things better. And the second one is about comment. Don't put comment if the code can already says that. So I think it's really crucial because sometimes I still see comment like you mentioned, right? The comment is totally wrong. The code has evolved maybe by multiple people editing it. So the comments did not get updated. So I think it's really crucial. Don't put comments if you don't have to. And the last one I think is very important, testing. I think almost everyone is talking about testing TDD, testing as a practice. And what you mentioned just now is about communication, right? It's not just for validation. I think there are still some examples that I saw from time to time that people just put validation as the main intent of test, but the test names, the test cases, all the things that are inside the test probably as just random variables and things like that. And it makes it hard for people to maintain and update over the time. So I think thanks for sharing that.
Tests as communication, and again, that idea of comments as communication, if we regard what we're doing in creating a code base, we're creating a system of knowledge and we want to communicate that. And when you start looking at it like that, you suddenly realize what you do want to do, but also what you don't want to do. And we also realize the half-truths. In other words, sure, tests do validation and verification. That's a part of their story, but that's not the whole of their story. They can tell us a lot more. And I think that idea, when we start stepping back and going, oh yeah, it's not just a mechanical thing, it's an intentional thing.